In this exercise, we look at an equation that arises in engineering and scientific applications. You are asked to consider an object which starts to move away from a fixed location at a constant speed. The graph shown is a distance-time graph. It shows how far, s measured in kilometers, the object is from the fixed location at subsequent times, t, measured in hours. You are asked to use the graph to answer several questions. We look at each of these questions in turn. The first question asked you to identify the dependent variable. Well, in this problem, the distance travelled s depends upon the time t. So s is the dependent variable. The independent variable is plotted on the horizontal axis, and the dependent variable is plotted on the vertical axis. You were then asked how far is the object from the fixed location initially. Well, initially means when time t equals 0, and from the graph we see that when t equals 0, s equals 100 kilometers. So initially the object is 100 kilometers from the fixed location. How far is the object from the fixed location after 4 hours? We can read this directly from the graph. After 4 hours, the object is 300 kilometers from the fixed location. How far has the object travelled after 4 hours? Well, initially it was 100 kilometers from the fixed location, and after 4 hours it was 300 kilometers from the fixed location. So the distance travelled must be 300 minus 100, which equals 200 kilometers. You're then asked how far has the object travelled after 1 hour. From the graph, after 1 hour the value of s is 150 kilometers. Therefore it has travelled 50 kilometers in the first hour. What is the speed of the object? We are told that the object is travelling at a constant speed. In the first hour it travelled 50 kilometers. So its speed must be 50 kilometers per hour. You are asked to state the vertical intercept for this straight line graph. And looking at the graph, we can see that the vertical intercept occurs when s equals 100. You are asked to write down the coordinates of 2 points on the line, and there are lots of possible answers. For example, when t equals 1, s equals 150. When t equals 2, s equals 200. So a pair of coordinates would be 1, 150, and 2, 200. Then you are asked to find the equation of the straight line. The line, being straight, means the equation is of the form s equals mt plus c, where m is the slope and c is the vertical intercept. We have already established that the vertical intercept c equals 100, and so we know already that s equals mt plus 100. We also know that the point 1, 150 lies on the line, and hence the values t equals 1 and s equals 150 satisfy the equation. We can substitute these values into the equation s equals mt plus 100, so that 150 equals m times 1 plus 100, or 150 equals m plus 100. The value of m which satisfies this equation is m equals 50, and so the equation is s equals 50t plus 100. What difference would it make to the shape of the graph if the constant speed of the object were greater? Well, if the speed were greater, then the object would travel a greater distance in a given time. Therefore, the slope of the graph would be steeper. What difference would it make to the shape of the graph if the constant speed of the object were lower? If the speed were lower, then the object would travel a shorter distance in a given time. Therefore, the slope of the graph would be more shallow or less steep. What would the graph look like if the object's speed was zero all the time? If the speed was zero, the distance from the fixed point would never change. The graph would be a horizontal line passing through the point 0, 100. Finally, you're asked to recalculate the equation of the line for the case when the speed is the same, but the object's initial distance is 150 kilometers. And you're asked in what ways are the two graphs similar? Well, if the initial distance is 150 kilometers, the vertical intercept becomes c equals 150. The speed is the same, 50 kilometers an hour. And so the equation of the line is s equals 50t plus 150. The graphs will be parallel lines.